Serene from TeachElectronics.com.
Hi, and I'm Richard.
And what do we got here?
What we've done is we've sent away for a kit, and it's an electronics kit. The idea is to allow this kit to help you build lab experiments in a DC electronics course that we have running at Udemy.com. So let's see what we've got.
So now when you say you have a kit, this is not a pre-made kit. This is a kit you made up by ordering the parts.
Correct.
Right?
There's not a kit per se, and I called every major electronics supplier and said, would you make me a kit? And I gave them the idea of what to do. And basically they all said no. Make it yourself, figure out what you want.
And then we'll sell it to you.
And then we'll sell you whatever you want to buy. So this would be what the student would get when they purchase the kit. So hopefully they would open this up and it's going to have everything they need to do the first 8 weeks of the DC electronics course. Well, I'll let you
have
do that.
something sharp and handy is my advice. Wow. They packed the heck out of this, I'm going to say. So is there there's nothing wrapped in that paper?
No, we're good there.
Awesome. So do you want to just go one at a time and tell me what these things are?
You know, if we're going to do it that way, let's do this.
Dump it out?
Let's dump it, because then the box won't be in the way. And I like being able to pick the things kind of in order.
Okay, sounds good.
So that might be helpful. The first thing here, and I'll show close-ups later, but the first thing is called a solderless breadboard, or it's called a proto board. It has both names. Its mission is to allow you to put electronic components in the holes in the board. So you can put a number of components in the board, you can build any kind of a circuit you want, you can test the circuit here. And the idea, the reason it's called proto board, is to prototype. You can build a circuit, test it, play with it, make sure it works the way you want before you actually do the soldering. So this would be the heart of the beginning of the kit. Let's see what else we've got here. In order to use a proto board, you need the ability to put the components on the board. And in the DC electronics course, the only components that you need are resistors. And I can see these are packaged well.
So if you had the proto board and the resistors,
then
you're almost all the way there.
There you go. You can plug the resistors in. You can connect them however you want using the board. Now you can't see this, but each one of these resistors, each pack is the same resistance. So if I look at these, they're all color-coded the same way. But each package or each set is a different size. And in order to do electronics, you need a number of different sizes. So you can see here we've got 20 or 30 different sizes of resistors. So these will wind up going into a little tool drawer box where you can keep them separate and keep them itemized. So that'll allow you to put the resistors in.
And now if you go to Wikipedia and type electronics resistor color code, you'll get a really good page I found this week that you might already know about that tells you what all these codes mean, how to read these colors, how to know what that says about the resistance and the tolerance of the resistor. And all that I know is English, but that doesn't mean I know what it means.
So these are spools of wire. They're solid wire. In other words, inside is a solid piece of wire. They're not stranded. They're not many strands of wire. So when you hook these resistors up, the next thing you're going to want to do is to connect them together using this wire. So this is called hookup wire, and this is how you're going to hook your components together. Now, in order to use the hookup wire, you've got to have the ability to take the ends off the wire so that you can expose the metal portion inside.
So they've got, is it rubber, plastic? What's the insulation on these?
It's like a rubber. It's definitely an insulation. I don't know specifically what kind of rubber it is, but the idea is that you take the end of that wire, you put the wire inside these clippy looking things. This is called a wire stripper. What happens is you put the wire in about where my finger is. When you squeeze down on the wire stripper, it grabs the wire and then it pulls the plastic off. So it pulls a short bit of the plastic off the end, each time that you squeeze it. So that's how you make your wire, and it looks like Sandy's going to let us try one of those out. So what you do, I look at the side of this, I don't know if you can see that, but there is room for several sizes of wire. So what I need to do is I need to look and double check which size I need, and I'm checking the size of the holes to the size of the wire, and that looks about right. So I'm going to take the yellow wire, place it in here so that the plastic part of the wire is in one of the little clip holes in the right size, I hope. And then I'm going to squeeze, and as I squeeze, that worked, the plastic is going to come off the end of the wire. Don't know if you can see that, but the yellow plastic is now gone from the last 1/4 inch of the wire. So we're going to use that wire to hook these components together.
Cool. So what's this little guy?
This is what you're going to use for power. This is a standard 9-volt battery. It's called a battery snap. I never knew the name for what these are called. You've probably seen those. This is the little snap that goes on the end of the square 9-volt battery. And then what we're going to do, we're going to run the red and black leads from the battery snap to 2 of these terminals on the proto board, on the breadboard, and this is going to be what provides our power for the circuits that we're going to use. We're going to hook up a circuit, then we'll power it up, and then we'll take test readings on that circuit to see how it works and what it does. And last but not least, this is called a digital multimeter, sometimes called a DMM or multimeter. So what this multimeter does is it allows us to take readings of electronic components, and we can come up with all of the various things in an electronic circuit. And we'll learn in this course that the 3 main things that we use are voltage, so we want to know the volts, and you know about voltage, the voltage of batteries. You have 9-volt batteries, 1.5-volt batteries, so you need to know the voltage. You need to know the current flow, how much current is flowing through the circuit, and you also need to know the resistance of the circuit, and the resistance, of course, is provided by these resistors. So what we'll teach you in this class is how to hook this meter up, and we'll look at where things are supposed to go. It looks like,
I was trying to do that.
oh, I see it. It's like a plug. It comes out.
Oh, okay.
Pull the end. So you pull the end of the little plug off, and we now have 2 connections, and there are 3 connections on the meter. We'll teach you how to use those and which 2 to use, but what we'll do is we'll put one of these connectors in one of the receptacles, we'll put the other connector in the other receptacle, and then what we have is the ability to read voltage, resistance, or current in an electronic circuit. So we put some batteries in this guy to power it up. We have a switch here that turns it from voltage to resistance to current. We can read all of the characteristics of an electronic circuit. So this meter will give us the ability to do that. So wow, we've got everything we need. Everything that I wanted is here. So we have a complete kit. So we're ready to start writing labs. We're ready to start fixing it and working with this to show the student how to use that proto board, how to put the resistors on there, how to read them, and what they need to do to get their circuits going.
And this is relatively inexpensive, right? This is like less than $100.
Well, yeah, I was hoping to get off real inexpensive. I didn't. This whole kit with tax and shipping and all of that came to $97. So yes, it's under $100. And I could have gotten a cheaper meter. This is worth about $20. I could have gotten one for about $10.
And then these are good.
Oh
snippers,
yeah,
right?
the snippers are important. This was like $19. I could have got it for $4 or $5, but you don't want a $4 or $5 wire stripper. Believe me, I've had them all, and they wind up falling apart. They wind up getting used up. The snipper wire cutters get dull. It's a real headache. I've had these over the years, and I'd say for the cost versus how long they're going to last you I think these are one of the best ones that you can get. So even though I spent a few more dollars on some of these components, the idea was I got you the best inexpensive kit that's hefty enough to do the job well.
And some of you will have some of this stuff already, so you could maybe not do a kit, but this is a lot easier than hunting all that stuff down yourself, I think.
So that's the kit for DC Electronics. Thanks for watching.
Okay, and then we'll take pictures of stuff. Pictures and pictures. And
Pictures
stuff
come
like that.
next.
Okay. Don't forget to like and subscribe, and we'll see you next time.